In this video, we're gonna build a doorbell that uses a magnet reed switch and uses a buzzer and capacitor, a couple capacitors, depending on how long you want to make it. You should get two of them at least of the same value. Put them in parallel. That makes them add up, and then when the switch moves, make sure that your magnet switch is a single polarable throw switch. If it's not a single polarable throw switch, it'll be always on when the door is closed. And that's why I couldn't finish it when I got into the parts from the vessel. I had to get two orders. I had to get orders from Walmart and order from All Electronics. So it's All Electronics. The switch that does that was back ordered. Anyway, so what I got here is I got one of these telephone modules that have this connector here. We're not using anything with telephone, just using the cable and connector, so that it can be extended, so I can use longer wires without having to solder it. If it's soldered to it, then the long wires and the door opens, it'll put stress on it, and it could yank the joint right off, or the tape right off. We don't want that, so what we do is we're going to use this flat telephone wire that has 4 wires in it, and I took both positive and negative, tied them together, not tied and shortened together. There's a pair with 2 for positive, 2 for negative, so that means that one wire fails in this thing, it'll still work. It'll just get from a different wire. Anyway, why I want to do it this way, because I want to plug it in and I don't really want to worry about the batteries going dead and then have to replace it. Of course you get these batteries, but the thing is, someone walks in and walks out frequency, it'll add up. Even though, yeah, you'll probably get a really long time where it's running off the batteries. Sooner or later, it's gonna have to be replaced, batteries. So to prevent that, we're gonna do it this way. And this way is actually cheaper too. The batteries, this way is cheaper because the cord here, this 25-foot cord here, is only like 65 cents at All Electronics. This is just a Velcro thing I was going to use for the back of it, but it comes with this yellow pirate stuff, stick stuff, and I'm going to use that and try that with it. I got the Velcro for that one there, that's holding this buzzer to the top of it, so that makes it so it's not hanging around and then falls right off. Anyway, I like this, and I didn't have to solder it all. All you had to do is twist the wires on the capacitors and put them together. And I put the new wire leads around the screws here. Then I found out. Then I took the screws that belonged to the other 2 wires that were not joined yet, and I moved from here to there to make it where we have a free empty space for putting wires to. Oh yeah, and right there, there's a resistor right there in parallel with the power supply. It's just provided there. Since the capacitors are 16 volts and the meter I have reads it out to the same. If you put a 9-volt power supply, since it's an unregulated one, since it's like a linear one, it comes up to 15 or so with no load. So I put that on there just to be safe, so the capacitors don't explode or break, just in case. Anyway, am I having the screen upside down? Anyway, so this should do us good. Then I can show you how loud it is. It's already plugged in. I just gotta do is take the, find out where's the wire, the red wire right here, the one that's not twisted together with the black wire. That's the common. That's why I have a wire to the common, so I know which one it is when it's just put together. And if I first when it's off, it'll make connection with the black wire. The switcher, I'll be able to turn on to the black wire. You see, nothing happens. That's because it'll be at a normally closed position of the switch, which means it'll be normally closed when it's not doing anything, when it's not switched on or not. Then it goes normally open, when it's normally open, which means that this won't make contact with that when it's on. Normally, when it's not on, when it turns on, it goes the other way around, and if you hear that, it's working, and there it goes. It's dimming as you hear, and soon it goes completely off. And I was lucky enough that I didn't have to put a transistor in there to power the whole thing, to power the buzzer. I had the only thing that could power it from was the capacitor. Seems like it doesn't need that much current. Some buzzers, they probably draw like 30 milliamps. You can think about LED. LED takes like 20. That's close to it. And if you probably notice, you can dim LEDs with it with capacitors one off of there, and it can last for a few seconds before it goes dead. Unless you get a super capacitor, it can last for hours. Thing is, I could have done that. I could have got a super capacitor for it, and then I can have it where it would have where in case the electricity went out, it would have backup power. But then again, it would be expensive, and the capacitor is probably bigger than this, probably bigger than these, and it wouldn't fit in there, and you couldn't get the case on it. So it's probably better to stick with those. Anyway, why I wanted capacitors to put in there was because I wanted it to be not constantly on once that the door is open. I don't want it to be constantly buzzing. I just want it to buzz once and then that's it. Just like a doorbell. If you wanted to do it even a cheaper way, but this way would mean that you'd have to use a power supply since it would draw, since it would drain the batteries real quick like. Not real quick like, it's because that it draws enough power that it won't last like a month or so, probably a few weeks, and you'd have to change it. Anyway. We did the other way around with the transistor, with making it where you want to stay constantly on when we're using a cheaper switch. That way, it been cheaper, but then again, you couldn't use batteries and constantly on. You can use a transistor to act like an inverter, which means that if you input a high into the base, the output of the base, if you input a high into the base, output of the collector will be low. It will be like off. When it's low and coming to the base, high will be out coming out to the collector pin. That there could be used for making it where because all electronics, the only ones they have in the switches were the ones that were single pole, single throw switch. And those there would make it where it'd be always on. It would make it hard to figure out how to charge the capacitor up and then discharge it to the buzzer, since you need to switch it between two different things instead of one. So the one they had was back ordered. So we got one from Walmart coming in soon. Probably on the 29th, I believe it said. And it would finish it, and then let's figure out how we're going to put it on the door to mount it. So, there you go. Very simple circuit to build. Now you have to wait for part 2 to come out. Thanks for watching if you like it.